All right, so I'm going to go through as many questions as I can here. If you need to watch this, you can. If you already understand how to do it, that's awesome too. All right, so these first section, we are just finding the slope. So at this point, hopefully we know the slope formula is y2 minus y1 over x2 minus x1. So that's what we're going to do on all four of these first four problems. I'm going to do number 4. Again, I'm going to label the first point as x1, y1, and the second point is x2, y2. So I'm going to take y2, and I'm going to subtract y1. On the bottom, same order, I'm going to take x2 and subtract x1. Anytime you have a negative back-to-back like we do here, it turns to a positive. So it happens on both of these. -7 plus a +4 is -3. -11 plus a +2 is -9. This fraction does reduce because both of these numbers are divisible by -3. So if you divide both of these numbers by 3, you end up with 1/3, and it's a positive 1/3 because a negative divided by negative is a positive. So the slope for number 4 is 1/3. All right, 5 and 6, you're doing the exact same thing. You're finding the slope of the line that passes through the points given in the table. So that means one line goes through all 4 of these points in both problems. We don't really know what the line looks like, but we know it goes through all 4 of those points wherever they lie. So that tells me it doesn't matter what 2 points I pick in this problem for my x1, y1, and my x2, y2. It really does not matter. So I'm going to pick the last 2 points for no particular reason at all. So I'm going to say 3, -2 is my x1, y1, and 7, -2 is my x2, y2. And then I'm going to do the slope formula. So I'm going to take y2, and I'm going to subtract y1. And then I'm going to take x2, and I'm going to subtract from it x1. And I already see I have the same y coordinate. So if I have the same y coordinate, this is going to be kind of one of those unique problems. -2 plus 2 is 0. 7 minus 3 is 4. So the answer is either 0 or undefined. Double check in the calculator, because a lot of us mess this up. 0 divided by 4, that's the one that gives you 0. So it's when 0 is at the bottom, the answer is undefined. So the slope for number 6 is 0. I'm encouraging you to pause the video and work out problems rather than just watch all of the video at once. And skip ahead if you know how to do some of these problems. All right, 7 through 10, you're finding the slope from this graph. You'll notice there's different slopes depending on what part of the graph we're looking at. So number 7 says find the rate of change, which remember rate of change, slope, same thing. So we want to find the slope in the first 30 minutes after takeoff. So that means we're finding the slope from this point to this point. Because you'll notice down here, only a half hour has passed. So that's 30 minutes. So we're just finding the slope between those 2 points, which you can either do rise over run, or you can notice this first point is the point 0, 0. And this other point is to the right 0.5, and it is up 24. So that is 0.5 for the x, 24 for the y. So x2, y2, x1, y1. And then just, again, y2 minus y1 over x2 minus x1. 24 divided by 0.5 is the same thing as 24 times 2. Takes 48 halves to divide evenly into 24. So the rate of change is 48 feet. And that's in thousands. So it's really 48,000 feet per one hour. Because the slope is 48 over 1. So that's altitude over hours. Doing the same thing on the next problem. I'll go ahead and help you get it set up. You're finding the rate of change from 1 hour and 30 minutes to 3 hours. So 1 hour and 30 minutes is this point. 3 hours is this point. This one, you don't need the slope formula for. We can see it remains constant. That's a flat line. So remember, think of our little dude here walking that line. There's no steepness to it. So the slope is 0 feet per hour. Number 9, find the rate of change from 4 hours and 30 minutes to when the plane landed. So 4 hours and 30 minutes is here, and the plane landing is here. So you're finding the slope where they landed. That point is 50. At 4.5 hours, that point is 4.5. I'm looking at the vertical axis, 16. So in number 9, you're finding the slope between those 2 points. All right, the next section, you are just identifying the slope and y-intercept of the line. So it looks like most of these, if not all, are in slope-intercept. So you need to know y equals mx plus b. So I've written that at the top of the paper. Remember, the m is the slope and the b is the y-intercept. So these questions asks us to identify the slope and the y-intercept and then graph it. So it's pretty straightforward. The slope is just the number in front of the x variable. So in number 11, there's not a number, but remember there's an assumed 1. And then the y-intercept is just the b value tacked on at the end. So it's the point 0, -4. So to graph this, we're always going to start with our b, with our y-intercept. So 0, -4 would be down 4 on the y-axis. And then we're going to use our slope to graph other points. The slope is 1, but let's rewrite this as a fraction because we know slope is rise over run. So that tells me we can go up 1, right 1. And notice how many times I'm doing it. You can do it an infinite number of times, or at least until that line runs to the end of the edge of the paper. So the rate of change of this line is we are going up 1 for every 1 we are going to the right. Of course, a line goes both directions, correct? So that means we went up 1, right 1, but we can also go down 1, left 1. Slope goes both directions. And there's our line. Let's look at one more, number 12. Number 12, our y-intercept is 0, 3. Just that point right there. Our slope is negative 1/4. Remember, we can write that 1 at the top, or we can write it with the number at the bottom, or we can write it with the number in the middle. Either one works. So graph your point, 0, 3. And then remember, rise over run. So this means we're going, the first way we wrote it, we're going down 1 and right 4. Because a negative 1 rise would take us down 1. A positive 4 run would take us right 4. And again, we can do this as much as we need to. And then if we take the slope the other way, the positive 1 over negative 4, positive 1 would be a rise up 1, a negative 4 would be a run left 4. And then graph your line. All right, and then finally number 17 says write the equation of the line on the graph. So again, we want to write the equation in slope-intercept form. So we need obviously two things. We need to find the slope, and we need to find the y-intercept. One of those things is super simple to find. That's the y-intercept. The y-intercept is right there because that's where it crosses the y-axis. So that is 0, 5. The slope is also pretty simple to find. We can do this two ways. We can say, okay, this is my x1, y1, 0, 5. And that is the point 4, negative 1. That's my x2, y2. And you can use the slope formula. Or you can use the fact that, okay, this line is going downhill from left to right, which means the slope is negative, and we can do rise over run. So I went down 1, 2, 3, 4, 5, and I ran 1, 2, 3, 4. So the slope is 5/4, but it has to be a negative 5/4 since we're going downhill. So the equation of this line is y equals negative 5/4 x plus 5.